Welcome to Ashley's Farm Insight. Across the cotton belt from Texas to Georgia, millions of acres turn white each harvest season. Yet behind this familiar landscape lies a high-tech industry navigating drought, rising costs, and global competition. In 2024 to 2025, the United States is projected to produce around 14 to 15 million bales of cotton, equivalent to roughly 3 million metric tons of lint, while global output is expected to reach over 110 million bales. So how does this small plant become one of the world's most essential textile fibers? Let's step into the field and follow cotton's journey from seed to fabric. Cotton planting typically begins in spring when soil temperatures consistently exceed 60 degrees Fahrenheit, 15 to 16 degrees Celsius. Farmers prepare the land using deep tillage equipment to break up compacted soil and improve root penetration. Many operations now use conservation tillage practices to reduce erosion and preserve soil moisture. GPS-guided tractors pull precision planters across thousands of acres. These planters place treated cotton seeds at uniform depths and spacing to ensure consistent plant emergence. Seed varieties are carefully selected based on regional climate, pest resistance, and fiber quality characteristics. Many farmers now use genetically improved varieties designed to resist bollworms and tolerate herbicides, reducing crop loss. Within days, seedlings emerge. Over the next 150 to 180 days, cotton plants grow into knee-high shrubs, absorbing sunlight and channeling energy into developing bolls, the protective capsules that contain soft white fibers. Cotton thrives in warm climates but demands careful management. Irrigation is critical in major producing states like Texas, where drought conditions can drastically affect yield. Drip irrigation and center pivot systems deliver controlled water applications to maintain plant health during peak heat. Fertilizer programs are timed to support vegetative growth and boll development. Nitrogen levels must be balanced carefully. Too much encourages leaf growth at the expense of fiber production. Pest pressure remains a constant threat. Bollworms, aphids, and other insects can damage developing bolls. Farmers rely on integrated pest management strategies combining biological monitoring with targeted pesticide applications. As harvest approaches, farmers apply defoliants chemicals that cause leaves to drop. This step is essential. Removing foliage exposes the cotton bolls and allows mechanical harvesters to operate efficiently while minimizing debris contamination. By late summer or early fall, the fields transform. White bolls burst open, covering acres in what looks like fresh snowfall. Harvest season begins. Cotton harvesting has evolved dramatically. Historically picked by hand, today's large-scale farms rely almost entirely on mechanical harvesters. Two primary machine types dominate. Cotton pickers. Modern spindle pickers gently remove fiber from open bolls without uprooting the plant. These machines are ideal for well-managed fields with evenly matured crops. Cotton strippers. Strippers remove nearly everything from the plant. Bolls leave stems and are used in regions where plants are shorter or weather threatens rapid harvest. Today's advanced cotton pickers are technological powerhouses. Many are equipped with onboard systems that compress harvested cotton into round modules, weighing up to 2.5 tons directly in the field. GPS technology optimizes movement patterns, reduces overlap, lowers fuel consumption, and increases harvesting efficiency. speed is crucial. Weather shifts during harvest can reduce fiber quality. A modern fleet can harvest thousands of acres in a matter of days. From field modules, cotton is transported to the gin. At the cotton gin, raw cotton undergoes its most critical transformation. First, modules are broken apart and fed into drying systems to remove excess moisture. Cleaners remove large debris before the fiber reaches the gin stands. High-speed saws or roller gins separate cotton lint from seeds. The lint, the soft fiber, moves forward for further cleaning and pressing. The seeds are not wasted. Cottonseed is crushed to produce cottonseed oil widely used in food manufacturing, while the remaining meal becomes high-protein livestock feed. After cleaning, the lint is compressed into dense rectangular bales, weighing approximately 480 to 500 pounds each. Each bale receives a unique identification tag, allowing full traceability from farm to textile mill. Once shipped to textile mills, cotton lint is processed through several stages. First comes carding, where fibers are aligned into thin strands. Next is spinning, where high-speed machines twist fibers into strong yarn. The yarn is then woven or knitted into fabric, dyed and finished. From denim jeans to medical gauze, cotton's versatility makes it one of the most widely used natural fibers on Earth. Cotton remains a cornerstone of global trade. The United States is one of the world's largest cotton exporters, shipping more than 80% of its production abroad in many seasons. Key markets include China, Vietnam, Turkey, and Bangladesh, major textile manufacturing hubs. Global cotton production in 2024 to 2025 is projected around 112 to 115 million bales, with Brazil and India competing closely with the U.S. for export dominance. Cotton contributes billions of dollars annually to the U.S. agricultural economy and supports hundreds of thousands of jobs across farming, ginning, transportation, and textile manufacturing. Price volatility, international trade policies, and sustainability standards all influence the industry's direction. Increasingly, growers are adopting water-saving practices and soil conservation strategies to meet environmental expectations from global buyers. Cotton today is not just fiber. It is a globally traded commodity shaped by technology, climate, and economics. Behind every bale stands a network of producers, engineers, agronomists, and gin operators. Farmers make data-driven decisions about planting density and irrigation scheduling. Harvest crews manage fleets of machines worth millions of dollars. Gin managers oversee quality control systems, ensuring fiber consistency. Across the cotton belt, communities depend on this crop for economic stability. Despite droughts, labor shortages, and shifting market dynamics, American cotton growers continue adapting, leveraging precision agriculture and innovation to remain globally competitive. From carefully planted seeds in spring to millions of bales shipped worldwide, cotton farming represents one of the most technologically advanced agricultural systems in modern production. Behind every t-shirt, pair of jeans, or cotton sheet lies months of crop management, advanced harvesting machinery, and high-speed ginning operations. This is not just a fluffy crop. It is a high-performance agricultural industry that continues to evolve. Thank you for joining us on Ashley's Farm Insight. We'll continue exploring the technologies, markets, and people shaping global agriculture.